Hello everyone and welcome to our special webinar. We're excited to give you a sneak peek into our latest ETAP 2024 release, its features, capabilities, demonstrate a few of these enhancements, and of course address how this release continues to drive safety, reliability, efficiency, compliance, and sustainability throughout the industry. Our team, as always, is excited to deliver ETAP 2024, a digital twin solution to design, plan, operate, optimize, and automate electrical power systems. ETAP 2024 offers an impressive new set of integrated power analysis modules, model-driven automation, and situationally intelligent solutions focusing on enhanced digital twin modeling and simulation with a fresh look and feel that we know you will appreciate. This major release includes new solutions and features, plus hundreds and thousands of enhancements and time-saving improvements. Throughout this webinar, we will showcase key improvements, help you understand what's new in ETAP 2024, and the benefits of upgrading to this release for your team if you're an end user and your customers if you're a consultant. So let's get started. For those of you who may be new to ETAP, the ETAP Electrical Digital Twin is built on a multi-dimensional foundation, enabling efficient design, analysis, management, operations, and a complete digital transformation of projects while adapting to evolving system changes. The concept, of course, of an electrical digital twin refers to a digital representation of an electrical system or a grid. It integrates various data sources and models to mirror the physical attributes and behaviors of the real-world electrical network. The 7 dimensions of an electrical digital twin can be understood as different aspects or components that contribute to its overall functionality and effectiveness. These dimensions typically include planning and modeling, design and analysis, engineering and commissioning, management and operations, assessment and maintenance, and of course system transformation and growth and sustainability. These dimensions collectively enable the electrical digital twin to be a powerful tool for managing and optimizing electrical systems, ensuring reliability, efficiency, and adaptability to changing conditions. ETAP offers an integrated electrical digital twin platform that's enriched with intelligent solutions that of course accelerates your energy transition from design to operations. ETAP Digital Twin goes beyond an integrated engineering analysis tool to provide an active blueprint of the electrical system that offers automated rule-based design, model-driven predictive analysis, a co-simulation platform, operator training simulation hub, real-time analytics, asset performance monitoring, and intelligent controls to ensure your electrical system lifecycle is safe, reliable, efficient, compliant, and sustainable. Imagine the lifecycle from design to operation as a continuous path, similar to the contour in a contour integral for, of course, our mathematicians who may be on the call today. As you move along this path, data is collected at each stage, similar to evaluating the function at each point on the contour. And just as you sum up function values along the contour to get the integral, you integrate and analyze data throughout the life cycle to continuously improve the process. By drawing this analogy for all of you engineers out there, we can see that continuous intelligence in the design to operate process is similar to performing a contour integral. Both involve moving along a defined path, continuously collecting and analyzing information, and integrating these insights to achieve a comprehensive understanding or optimization of a system. This continuous process of data collection and analysis is key to driving improvements and making informed decisions, much like how a contour integral helps in understanding the behavior of a complex function over a given path. So that's enough of the mathematics, and let's get down to the ETAP 2024 release. And we're super excited to first of all share the full list of the new features and capabilities and highlight the key improvements and enhancements that we know you will love. And the very first one, of course, is the modern ribbon user interface. And this is a game changer in the way you have been utilizing and interacting with ETAP. And we're confident that this change, though is a drastic change within the way the user interface works, will completely make a difference in the way you are able to operate and manage the program in a very efficient manner. And of course, we've done our best to provide new features and capabilities that go along with the ribbon interface. The other thing that we have, of course, enhanced on the one-line diagram is the way we are able to interact with objects, including dragging and dropping. And of course, we've enhanced the way you're able to link information to your ETAP model and, of course, visualize and interact with that information. We have a brand new module, which is AC control circuit diagram, that allows you to simulate AC single-phase control circuits, particularly in our control panels for instrumentation and control. We have another new module, which is feeder hosting capacity, that's used to simulate and analyze the amount of renewable energy that can be hosted in a distribution system. We have added a full new innovative dimension called sustainability analysis, and we're super excited about this new feature because this is at the core of the purpose of our organization. And the purpose of sustainability analysis is to improve electrical designs with a whole new dimension that has never been previously analyzed. We are also supercharging compliance and efficiency by enhancing our grid code solution by including grid code analyzers and new expanded capabilities. We have improved our cable sizing and enhanced it by including compliance tables from NEC 2023. We've expanded our offer for Australian standard cable sizing by including shock and thermal protection based on Australian and New Zealand standard 3000. And of course, we are staying current, we're staying ahead, and we want to stay safe. And we've also continued to enhance our arc flash module by including NFPA 70E 2024 and of course the Canadian standards. Lightning risk assessment allows you to graphically assess the risk of lightning and the adequacy of your lightning protection system. And for this purpose, we've also included a new standard, which is IEC 62305, making this a comprehensive graphical lightning risk assessment module. The substation ground grid capability has also been enhanced, including a new methodology, which is IEC 50522, in addition to the existing IEEE 80, as well as a finite element method. Staying with the theme of safety, we've also added the ability to display and verify energy and current limiting capabilities of molded case circuit breakers and cables so that you can, of course, visualize the capability as well as size the conductors and the molded case circuit breaker protection accordingly. We've also added the ability to simulate the transients with respect to DC arc flash. And of course, with the proliferation of energy storage devices, this is a key capability that is now part of the DC arc flash module. DC arc flash also includes our innovative C area methodology for increasing the efficiency at which you can conduct these arc flash studies. And of course, the C area methodology already exists in the AC arc flash module. You can also, of course, use ETAP to assess and improve power quality. And for this purpose, we've also enhanced our unbalanced harmonic analysis module to include unbalanced network frequency scan. And as the name suggests, it allows us to scan the frequency and plot impedance versus frequency for each phase individually, particularly useful for single phase systems. And of course, we've also enhanced the way we do our passive filter sizing by increasing our offering from not just a single tune filter, but also including sizing for high pass, third order damped, as well as the C-type filters. And of course, with, again, proliferation of energy storage devices, renewable energy, comes the core component, which is inverters or inverter-based resources. And of course, there's been latest changes in the harmonic standards, particularly in IEEE 519. So ETAP 2024, of course, includes compliance and rules based on IEEE 519 2022, based on IEEE 1547, as well as IEEE 2800, in order to make sure that you are up to date with the latest standards that are needed for power quality compliance. Of course, to also tackle the new energy landscape, we need newer components as part of our digital twin offer. And the very first component that we've included as a new digital twin component for modeling and simulation is DC power capacitor. We've also enhanced our grid interactive smart inverters by including additional control modes. And we've added yet another digital twin component, which is auto transformer, including 2-winding and 3-winding modeling capabilities. We have a brand new module, which is a game changer within our industry. And this module is unified transient and protection. As simply as I can explain it, it allows the combination of dynamic stability analysis with the complete protection evaluation, not just instantaneous, but also overcurrent, distance, out of step, fuses, breakers, relays. Everything is included within this evaluation along with our stability program, which makes it a very unique offering that allows you to do these assessments at a single click. We've also enhanced our dynamic or transient stability program to include all sequences, visualize the sequences, and of course plot those sequences graphically on the one-line diagram as well as our plots. And we've also enhanced the way that we model differential relays. And of course, in ETAP, we include generic differential relays with restricted earth fault, which is a new capability. But in addition to that, you can also model vendor-specific differential relays, allowing you to move closer to the physical device along with its labels and tags. We've also made it very, very simple to make our customers go from design into operations. When we're moving from design to operations, we use the same electrical digital twin and connect it with the real-time operations data. And in fact, in certain cases, ETAP can also act as a SCADA system, allowing you to not only monitor and perform predictive simulation, but also control the electrical system, especially in the absence of an electrical SCADA. Now, of course, this digital twin has to be updated incrementally because there are always design changes that happen within an electrical system on the engineering side. And these could be future changes or adaptations to the engineering design. And the ability to then move these changes into the operation side has been streamlined and made more efficient in ETAP 2024. We are, of course, also improving our network project management, which allows us to collaborate on the same ETAP project at the same time. And we've drastically improved the performance of this collaboration tool, especially when we're dealing with large distribution systems with over 1 million components, making sure that your experience with ETAP is as enjoyable and seamless and streamlined as possible. We've also enhanced eProtect. eProtect is part of our centralized enterprise asset management solution. eProtect communicates with field protection relays, and it also communicates with ETAP Star and Star Z in order to manage the location, information, and settings throughout the life cycle of protective relays and other electrical assets. It's an invaluable tool, of course, for transmission NERC PRC compliance, but it's an invaluable tool also for mission-critical facilities such as industrial systems, data centers, and so much more. So now that you have an overview of some of the key enhancements and features within ETAP 2024, let's dive into the details. So the very first capability, of course, is the modern ribbon interface. And of course, the modern ribbon interface allows you to not only enhance your productivity. It also allows you to create your own shortcuts so that you can set up and have the tools available that you need exactly when you need them, including customizable quick access buttons. The ribbon also allows you to, of course, change the way you visualize the one-line diagram as well as the application interface. So, of course, you can switch between various color palettes that suit your working environment, including going all the way into a dark mode environment as well. It also features a centralized backstage area for file management, settings, and of course other essential functions such as reviewing your license configuration, allowing you to use and change your preferences, and of course the printing options that are part of the backstage as well. So let's take a look at our first set of capabilities in action using ETAP software. The very first one, of course, is the modern ribbon interface. Now, back when we developed ETAP in the early DOS days, it had a particular user interface and it was quite graphical for that period in time. We then moved to a Windows 95 interface, which was a huge leap forward, not just in technology, moving to a 32-bit platform, but it was a brand new interface. We then later on moved to a 64-bit technology, which was again another leap. And now we are introducing this ribbon, which is another leap in terms of the user interface and the visualization of the software. And we call this a power ribbon because it not only allows us to convert our classic functions into a ribbon, but it also gave us the opportunity to bring all of our expertise together and ensure that when we put these functions together, they are done in a manner that is easy for our users to navigate and use, such that it is fluid in the way you understand how power system analysis is typically done. So let's take that and see a few of these examples. Now, of course, before we begin, you can also, first of all, select whether you want to go to dark mode, gray mode, or light mode. So this is completely up to you in terms of your preference. You can also control the quick access toolbar in terms of what functions you would like to have. And of course, though this is a power ribbon, it has been configured the way we understand our users would like to interact with ETAP. You have full control over making sure that you can change, maneuver, organize, and even create new tabs and functions the way you would like to. And once you create and customize the ribbon, you are able to, of course, export or import your changes, especially if you're moving from one computer to another, or if you would like to essentially make changes on your machine that are different than the default that has been provided by ETAP. So these capabilities, of course, exist in terms of customization. And of course, the first thing that we would do is build the diagram. So of course, you can simply drag and drop and build the diagram by using our edit or modeling mode. But now the changes start to appear when you move into a study group. And within the study groups, we have organized different modes. And these different modes, for example, in PowerFlow include load flow, unbalanced load flow, time series load flow, allowing you to switch between these different modes. And whenever you pick the mode that you want to run, you can simply run the analysis based on your study case. You can see your output reports. You can interact, of course, with the display, including turning the animation on or off. You can plot the analysis wherever the plots are available. Look at the alerts or overload conditions in this case. Open up the analyzers, especially if you're analyzing multiple scenarios. And then also interact, of course, with the multi-dimensional database, such as the presentation, configuration, and revision. And of course, also create and run your what-if analyses either individually or as a batch using our study wizards. So it's quite fluid, going from analysis to report to visualization. And of course, at the end, any of the what-if analysis that you want to package and rerun for later use. So once you understand the fact that there's a group and there are certain modes, every single mode works exactly the same. Now, we've not only just converted our analysis and organized them, we've also made them a little bit more intelligent than the past. And one example of that is the way our study cases work. If you have an IEC standard, as soon as you select the standard that you would like to run, you get the study cases that you have created for that particular standard. If you switch back to ANSI, then you'll get the study cases that you created for that particular standard. So there's also intelligence built into the ribbon at the same time. Now, of course, the other tabs are self-explanatory in the sense that the view tabs have everything related to the view and visualization of the application itself. Tools include things that are not part of a particular mode. We have references such as library, warehouse, and rulebooks that you can interact with. There are collaboration tools, including import, export, as well as our NetPM or project management tool. The project itself includes all the initialization parameters that you use to initialize your project and make your project execution smoother. And the modeling phase includes ability to interact with the diagram, including, of course, turning things on and off as service, opening, closing breakers very quickly, are all available on the ribbon. So many of the functions that were available in the context or right-click menu are also available on the ribbon at the same time. This is how the ribbon works in ETAP 2024 and how simple and straightforward it is. And if you are one of those people that likes to use a combination of keyboard as well as a mouse, you can also take advantage of that fact within the ribbon by simply typing in a command and choosing from the available commands that are within that ribbon. So in this case, I want to simply run a load flow, and I can select and run that analysis by just typing in a command. If you want to go ahead and make changes to your default loading categories, then we can bring up that editor very, very quickly. So in case you find yourself struggling in the beginning to see where a particular capability may be, you can simply type in the command and the shortcut will guide you to that function. So that is the modern ETAP Power Ribbon in action in a very, very short period. And of course, I welcome you to download the latest ETAP 2024 release, try it out, and of course, attend one of our trainings, and we'll be happy to go into a lot more detail on how to best utilize the Power Ribbon, including customization of the ribbon options themselves. Now, one of the other things that you can do with ETAP 2024 is simply embed information such as files and images directly into the single line diagram, including PDFs, document files, Excel files, images like JPEG, PNG, etc., by simply dragging and dropping things from your computer, like your desktop or your downloads folder, into the one-line diagram, and it will automatically attach that information into the diagram and actually save that information with the ETAP diagram itself. So let's see that capability really quick in action as well. So let's say, for example, you have a transformer and you went and got a nameplate for that transformer. You want to simply embed the nameplate information right next to the transformer for some reason. You can simply drag and drop the image file and drop it into the diagram, and as you can see, it's a plain and simple insertion of the image. And you can of course right click, go into its properties, and interact with the image, including deleting the image once you're done with it. And of course, you can also drag any other image for that matter, including this particular image, giving us a one lion diagram. Now, of course, you can drag and drop and embed images into the diagram, but that could make your diagram look quite complicated. It could make it look a bit messy. So you may want to take on a different approach. And for that purpose, we've also added a new capability, which we call document tagging. And with document tagging, you can maintain and manage links to multiple documents in a tabular and searchable view. So let's take a look at this capability in action really quick. So we're back to our ETAP software, and you can simply open up the document tagging tab from the bottom pane. And as you can see, there's already a few tags that have been inserted or created for this particular project, including the ability to show the link icon, as well as a QR code associated with that particular piece of document. Now, that document could simply be a URL to a website, it could be a URL to a SharePoint site, or any other document repository. And of course, as before, you can drag and drop and simply insert exactly that particular image that I use for the nameplate, or that other graphic that I use for our one-line diagram. And by doing so, you can simply create a list of all your document links without actually inserting them into your tab. And then, of course, you're able to show them in the data block, create a QR code, and, of course, search for the information at the same time once you have many of them. The advantage, of course, for this is for every single device, you can have links to the catalogs, the vendor catalogs, the setting files if they are stored externally, manuals, maintenance information, pictures, or any other information that's associated with that particular asset, all in one place. So that's essentially document tagging. We've also enhanced the one-line diagram to include annotation shapes. So with the annotation shapes, you can simply drag and drop a text box. You can choose to either add the text to the annotation shape, or simply just change the shape of the annotation, including borderless text boxes. You can even add QR codes into the text box itself, allowing you to also, of course, annotate the diagram similar to what you would do in a CAD drawing. And of course, the goal is to essentially try to put all of the annotations that you would like to have, such as future expansion, spare, or any other annotations that do exist, directly on the ETAP diagram. And of course, by having ETAP allowing you to create more than one presentation view, you can have a presentation view such as OLV1 or OLV2 set up, one for analysis and of course one with annotation. That way you can make sure that your study presentation is pristine as compared to your annotation presentation that has all of your annotations saved and printable at the same time. So very quickly, these are the annotation shapes that are available in ETAP 2024. The other enhancement that we've done is the enhancement to the component toolbox. You can not only search for the components using the search toolbox function, but you also have the ability to access all the centralized building methods such as auto build, auto complete, and auto connect all in one place. The icons themselves have become scalable, so you can change the icon size without any distortion because all icons are vectorized. And you can essentially also have your component favorites, which is a huge advantage. By simply bringing in a few of your favorite components, you don't have to search through a long list of the components that you would like to use to build the diagram. So the component toolbox also has been enhanced. We've also enhanced our license manager with over 30 enhancements towards improving our cybersecurity profile in order to stay ahead of any vulnerabilities and ensuring that there's even more tighter protection for the licensing and the way the license manager communicates with the ETAP software. And at the end of the day, you will find, of course, improved compatibility of the ETAP license management with other licensing services that exist on the same machine at the same time. And of course, we've also improved the reliability of our automated keyless license exchange for more easier and effortless installation, again, with the intention of making the effort of installing and maintaining ETAP, particularly for the IT personnel within your organization, more simpler, more easier. ETAP includes not just a one-line diagram, but also includes a geospatial diagram. And within this geospatial diagram, we've also enhanced it to not only show you geospatial information of the feeders and the distribution system, whether it's for a utility distribution system, airport, oil and gas distribution, regardless of the type of system. If you have geospatial data and if you want to visualize it, you have the ability to visualize it as a schematic on the one line or as a geospatial diagram. Now, within this capability, we've also enhanced the way we can visualize protection relays. So you can also show protection relays on the one-line diagram that appear on the geospatial diagram, giving you a complete holistic substation view, not just on your one line, but also on your GIS. And these protection relays and instrumentation are synchronized with the one-line diagram as before to ensure that there's consistency of data between the schematic as well as the geospatial diagram at all times. We've also added 3 new digital twin elements. The first one is auto transformer, which is 2 winding and 3 winding auto transformer with both ANSI and IEC symbology. And we've also added a new component, which is a control power transformer, which is slightly different than a voltage transformer in the sense of the capability, its rating, as well as its sensitivities. And of course, we also have added DC capacitors that allow you to model and simulate more details for renewable energy railway systems, as well as other pulsed power applications. When it comes to digital twins, we've also enhanced, of course, the passive filter, including additional sizing. We've added the ability for the power grid to be standardized as a single phase object rather than using a phase adapter with a 3-phase power grid. So allowing you to build a single phase network off the bat from the power source directly. And we've also improved and included the long line modeling of transmission lines and cables, especially for transmission and long distance marine cable system applications. So let's take a look at all the improvements that we've done for our design solutions. So the very first one I would like to tackle is sustainability analysis. Now, sustainability analysis, as I had mentioned earlier, is a new dimension and a new innovation from ETAP to ensure that when we look at an electrical design, we look at it from more than one dimension. The current dimensions that exist include technical losses. So we have a technical dimension to look at design A versus design B. We have another dimension, which is reliability, such as failure rates. So again, we can use failure rates to compare effectiveness of design A versus design B. We have economics, again, that is used to measure or gauge the effectiveness of the design. We have stability or resiliency. So we use analysis like transient stability or other mechanisms like voltage stability to understand how resilient or stable is this particular design under various conditions. And now we have sustainability that allows us to use the lens of carbon and carbon footprint and carbon emissions to understand the sensitivity and the capability of the design as yet another dimension. So it's a great offering for especially our consulting users who would like to provide value to their customers. In addition to the standard design comparisons that you are able to provide, you now have another dimension to show the effectiveness of the design. It's also an excellent tool for vendors or equipment manufacturers to make sure that they are also able to show that their new equipment has more efficiency and has a better carbon footprint than the current equipment that may be in place in the electrical system today, ensuring that there is yet again another dimension to brownfield design upgrades. So when it comes to sustainability analysis, in the current version, which is ETAP 2024, we handle scope 2 emissions, and we're able to inspect carbon dioxide emissions of the electrical network operations. And we do this by simulating the emission scenarios and understanding the outcomes based on the power consumptions and allowing you to select the optimal design criteria. And at the foundation of this includes a time series power flow that allows you to run and compute your carbon footprint, not just for maybe an hour, but you can do up to a year or multi-year evaluation, especially when it's a brand new system design. So let's take a look at the CO2 sustainability analysis module in a little bit more detail using the ETAP software. We can simply switch over to our time series load flow module, and we are able to access our sustainability analysis. Sustainability analysis is a unique offering that allows us to interact with not only the study parameters, but also the study results using a graphical interface. We of course have all the information related to the details of what is covered in this particular module, including the specifics of the parameters. But we can of course begin with various regions to understand how the utility side is providing or contributing to the carbon footprint of your electrical system. And you can essentially choose the footprint based on the latest information available by downloading this information using the API that we provide from ETAP software. And once you have the utility carbon footprint, you can essentially create a new sustainability analysis for your particular system and plug in the emissions parameters based on the way your system is actually configured. And once these parameters are configured, you can save your scenario. You can, of course, go ahead and create multiple scenarios in case you want to compare as designed, as upgraded, or a design B or a design C scenario. And then when you go ahead and run that particular scenario, we are essentially automatically triggering ETAP using our Python API to make sure that we are running the necessary analysis that we need to run within the ETAP software. And we essentially give you all the results in a summarized view back into the sustainability analysis web interface. So once the study is completed, we provide the results in multiple formats, including a CSV format, a report format, which is in a Word document format, which includes a deliverable report, not just the study results. And the study results themselves, if you would like to see them, are also included in a tabular format, including the carbon footprint, not just for the source or for the total system, but also for every single component within the power system network itself, allowing you to not just look at the overall carbon footprint of the network, but actually zero down into the components that are contributing maximum to your carbon footprint profile and really put the microscope on those components in terms of change or upgrades and further justifying the need to change or upgrade those components, in addition, of course, to the reliability of those components. You can also, of course, visualize this information using a dashboard, which is a very high quality dashboard that is produced, including the ability, of course, to configure the dashboard, how it's arranged, and also visualize the information in a way that is easily understood by non-electrical engineers. So that is sustainability analysis, which is a new innovation in ETAP 2024. The next module we want to look at is feeder hosting capacity. In short, feeder hosting capacity implies the ability to use optimization to accurately simulate and analyze the location and the size of a distributed energy resource, such as a solar panel on a rooftop, using geospatial or a schematic representation of the network. So imagine you have a distribution feeder that does not have any solar customers or any residential customers with solar on their rooftop, and we want to understand how much of renewable energy can be put onto that feeder, where can it be located, what is the size, at a system level, which is at a feeder level, or at a granular level per particular height, which is at a feeder level or at the household level. And of course, we use 3 different analyses with 3 different perspectives, allowing you to get the answer that you need in order to make these decisions in the correct and impactful manner. So let's take a look at feeder hosting capacity very quickly using ETAP software. So here we have a very simple distribution system that is already in feeder hosting capacity mode. And we have three different study options, including nodal feeder hosting capacity that allows us to compute the hosting capacity in kilowatt at every single bus. We have a stochastic feeder hosting capacity optimization that is used to find the overall minimum and maximum allowable penetration for that particular feeder, and it's also able to visualize this using a scatter plot of voltage, which we'll take a look at. And of course, we have another capability, which is feeder hosting impact analysis, which is used to view the variation of maximum voltage based on incremental change in PV penetration for certain selected inverters. So it's really meant for pinpointing the impact of incrementally increasing solar output in a specific location and seeing how the voltage can vary when you increase the hosting capacity at a very specific location. So you can optimize the entire system in one shot. You can see the overall limits of your feeder, and you can also zero into a specific location and see the impact of hosting on a particular bus or a particular location. Now, when we essentially run one of these scenarios, such as the stochastic optimization, as soon as the analysis is completed, we are of course able to visualize the animation, the flow within the electrical system, including the kilowatts and kVARs, which in certain cases may move in opposite directions. We're of course also able to visualize this via a contour, so you can see the areas of higher voltage versus areas of nominal or lower voltage. And finally, of course, we're also able to see the same information using a plot where you can see power versus voltage or penetration versus voltage, and graphically visualize it through a scatter plot and understand where your hosting limits exist within the system and the level of penetration that may exist within the system. So very quickly we can see our voltage limits, the hosting capacity that we can have, which is within the green area, and we can see that we're at about 2 megawatt of hosting capacity and at about 240% penetration, which is our maximum limit for this particular system. So very friendly, very easy to use interface, and of course very intuitive at the same time, where you can also see bulk of the power that's being exported out into the system, and of course some of it being consumed by the residential customers at the same time. We've also included AC control circuit diagram, and as you can see, when you use the AC control circuit diagram, it's computing the voltages as well as the sequences of the way a control circuit diagram operates, which includes, of course, the contacts, the solenoids, the Form C contacts, and because this is AC, we also include the power factor and the current angles associated with an AC control circuit. And this is connected to the ETAP single line diagram. So within this diagram, not only do you have your electrical power system information, but you also have the control wiring information along with the voltage drop, the sequencing, and the validation of the sequencing to ensure that when you press that button to either start, stop a motor or to open and close a circuit breaker, the control circuit will work adequately. Of course, most systems are designed with these control circuits to be operated nominally, but AC control circuit diagram is particularly beneficial if you want to also analyze cases where you're not only designing the system, but you also want to make sure that the system operates correctly under degraded voltage conditions, or in cases where your operating voltage is off nominal and you want to make sure that your safety and shutdown systems have adequate voltage and they operate correctly. So these are some of the applications for AC control circuit diagram, including the graphical animation, an extensive equipment library, and the ability to analyze the operating states of the control devices with a detailed sequence viewer. Within ACCSD, we also do a step-by-step simulation. We are able to simulate the logic interlocks, and we also include the modeling of the device burden and the inrush modes. So quite detailed modeling of every single individual control circuit device, put together into a control circuit diagram, powered by a control power transformer that's ultimately fed by the ETAP single line diagram. ETAP grid code allows you to automatically perform grid interconnection analysis and compliance, such as including automated evaluation of real and reactive power capability, harmonic distortion, and fault write-through, all with the single click of a button. We can essentially utilize different types of rule books, include them as part of the study, and allow you to perform the analysis using different events and provide the results of the various analyses into a single report where you can visualize not only in a tabular fashion, but you can also visualize the outcome of your grid code compliance study with the help of plots and quickly make assessments whether your bulk energy power system is compliant with the grid code requirements and what you need to change to improve the compliance for that type of facility. So in ETAP 2024, what we've enhanced is the ability to have a dedicated renewable energy group. So we have a new group that's dedicated for grid code analysis, and we've combined all of these different grid code analyses into a single group so it's easy to access. We have new study case options for selecting power plant controllers. So power plant controllers allow you to not only define the assets within a particular power plant, but it also allows you to make sure that you can include more than one power plant as part of your interconnection study, which is quite unique. What that essentially means is you can have two different points of couplings into the same substation and manage each power plant individually and even do power plant control of each section of the power plant individually. So it's almost like having subsystems within a main system, and it's managed through a dedicated power plant editor and dedicated power plant controller. And of course, you can also see various rules or rule books within the grid code, and we continuously keep improving and enhancing the various grid code rules as they pertain to various utilities that correspond to various geographies within the global landscape. So those are the quick enhancements that we've done for grid code. And when it comes to the power plant itself, as I mentioned earlier, you can define your sources of active reactive power and define more than one reference point of compliance by using the power plant controller, and then have your automatic power plant rating calculation done, including the alert checking when you violate those power plant capabilities. So moving on to the next capability, which is our arc safety solutions that's made up of AC, DC arc flash as well as high voltage arc flash. We've of course added a new arc flash ribbon with the ability to filter the scenarios, so you can quickly filter between ANSI IEC standards and filter your study cases. Within arc fault, we've added a new method, which is an instant energy subtraction method, and it's a major improvement to arc fault itself. And we've of course updated our shock boundaries and energy levels based on NFPA 70E 2024, as well as the Canadian standard Z462 2024. And of course, we've also enhanced the ability to generate work permits from within ETAP itself through these continuous improvements of the shock boundary and energy levels from the new standards. We've enhanced our DC arc flash module by including transients for Stokes and Openlander, as well as the German standards DGUV 2003 methods. And this transient DC arc flash also includes the ability to understand the elongation and the erosion effect of a DC arc flash, which is also quite unique and detailed in terms of the simulation of the behavior of the arc energy. And then we're able to plot the incident energy as well as the arc energy current voltages and the bolted fault current, giving you a realistic picture when we have a short circuit, especially in a system that has energy storage devices, where the fault current increases and then decays, and it does not sustain continuously, and how that changes the arc energy calculations is all automatically taken into account with this DC transient arc flash module. And we've also added the enclosure reflectivity multiplication factor for the maximum power method, that's used for DC arc flash as well. Within DC arc flash, we've also added the ability to perform the analysis using constant energy area boundary curves, or as we call them, C area curves. This is a unique capability within ETAP. DC arc flash also includes constant energy area boundary curves in ETAP 2024, or as we call it, C areas. Using the C area methodologies, we can essentially improve the efficiency of the arc flash assessment quite rapidly by automatically updating the minimum and maximum bolted fault currents. And once that is done, you can analyze numerous arc flash input data variations without the need for creating any additional scenarios. And by creating various combinations of the input data variations and using maximum and minimum short circuit currents, you can get a boundary point, a curve, or an area of energy that gives you an indication of what are the possibilities of the fluctuation of the arc energy under various conditions. And using that area, you can get a certainty region, which can help you determine the correct protective device settings and make your protection and coordination study more reliable when you have a situation where the data itself is not as accurate. So therefore, without knowing the accuracy of the data, you expand the possibilities, and then you use the possibilities to use or to set your protective device settings, which can give you more reasonable arc flash results more quickly and get you into compliance in a faster fashion. So that's DC arc flash. We've also enhanced our lightning risk assessment module, which is used to assess the risk of lightning strikes and the probability of damage in compliance with certain international standards. And within this lightning risk assessment tool, we can of course assess the risk of lightning striking a structure due to the lightning flashes. And we currently comply with various standards for lightning protection system evaluation, such as NFPA 780, 2014, 2020, and now with the new version of ETAP 2024, we comply with IEC 62305, which is a standard for protection against lightning and risk management. And we also have project templates now based on this new IEC standard. Within the lightning risk assessment tool, we've also enhanced our graphical equivalent area analysis for complex structures. So it essentially allows you to not only consider the effect of the lightning protective devices and the lightning protection systems, but it's actually done for multiple zones at the same time. So what does that mean? We can take multiple power lines, telecommunication lines, adjacent structures, as well as user-defined high and low risk zones, combine them together into one system, and then analyze that one system all at the same time, versus analyzing each zone individually and then coming together to perform an overall analysis of the lightning protection system. So with this calculator, you can perform the lightning protection for the entire facility all at the same time, essentially saving you time and improving the efficiency of the design. For lightning risk assessment, we've also added comprehensive Excel reports, as well as error checking of the data to make sure that the validity of zones as well as the incoming lines are validated, and we provide warnings when the data is out of sync. And we also have added alerts when the user-defined or the default risk tolerances are being exceeded. And of course, lightning risk assessment requires input from weather data such as lightning frequency, and the lightning frequency maps and the flash density data has also been expanded to include more parts of the United States as well as global regions. And you can also include a drawing area of the lightning protection system evaluation for structures up to 6 square kilometers, allowing us to model very, very large structures and analyze them in multiple zones all at the same time. Within ArcFlash, of course, one of our output is ArcFlash labels to ensure that we have marked the equipment with appropriate safety labels, and the labels should of course include the energy as well as the appropriate PPE that's required to operate that equipment when it's energized. And of course in ETAP we include e-label maker, which is a graphical tool for creating these arc flash labels. And of course, we've enhanced these labels to make them more modern in terms of their look and feel, as well as added additional capabilities and new templates, allowing you to configure the label exactly the way you want based on the pre-existing templates that already exist. Of course, if you want to create your own template, you can of course do so within the label maker and populate it with the arc flash data in a batch all in one shot. The ETAP Harmonic or Power Quality Assessment Group allows you to perform faster and easier assessment of harmonic distortion and its mitigation techniques using various components that are already available within ETAP, including all the power electronic devices, including inverter-based resources. Within harmonic analysis, we've of course enhanced the program to now include rule books associated with IEEE 1547 as well as IEEE 2800 that include the total rated distortion as well as the reference point of applicability. And these rules are now added to the existing rule books that we have for harmonic evaluation, including Australian standards, British standards, European standards, and of course, North American standards. We've also improved the harmonic analysis module to comply with the new changes in IEEE 519/2022, including the updated compliance limits and updated definitions in terms of point of interconnection and point of applicability or compliance. Within harmonic analysis, we've also enhanced the derating evaluation for transformers and cables based on ANSI C57.110. And you can also use ANSI C57.110 for transformer K-factor evaluation in order to ensure that you have the right capacity of transformer when you're applying it to a system that is rich in harmonics and making sure that the transformer MVA capability can withstand the current going through the system in addition to the fundamental current. We've also enhanced our harmonic spectrum library by including interharmonic spectrums as part of the standard library offering that we provide from ETAP as part of the master library. When it comes to unbalanced harmonic analysis, of course, you can use ETAP for performing the single phase unbalanced harmonics, including a waveform and vector visualizer. And we include the effects of harmonic mitigation, such as active and passive filters, when we perform unbalanced harmonic analysis, along with all the necessarily harmonic modeling, such as the long and short line modeling. So this is an existing capability within ETAP, which is unbalanced harmonic analysis, which has also been enhanced in ETAP 2024. Related to power quality is passive filter sizing as part of the mitigation technique to essentially improve overall power quality and reliability. And of course, the static filters are of multiple types, including notch type, high pass, and third order, C type, and damp type. And these static filters have been enhanced to make sure that we can automatically now size the high pass damp filters as well as the third order, including their subtypes, automatically within ETAP at a press of a button, making sure that you can size the filter not only for power factor correction, but also, of course, for harmonic mitigation, both at the same time, while considering the economic impact of sizing these filters. So with the passive filter sizing being enhanced, you can plug in either a notch filter or a high pass or third order filter and have ETAP size those filters for you. When it comes to renewable energy, we've also enhanced our UDM module to include alkaline electrolyzer dynamic models. You can now use UDM and the electrolyzer models that are available in UDM in conjunction with the models that are available within the ETAP controller element and simulate and analyze the green hydrogen production within ETAP. So this includes the electrochemical cell behavior, the thermal characteristics, as well as the hydrogen production rate and its storage, along with the necessary compression components that are part of a green hydrogen production facility. And this UDM model can be then used along with the transient analysis as well as steady state analysis to make sure that you can get the complete picture of a green hydrogen plant from its process as well as its electrical side combined together. ETAP transient stability, of course, is an existing module that ensures that you can perform any kind of what-if analysis, create any kind of disturbance, and test your network resiliency by accurately simulating and analyzing the dynamics that are created as a result of these system disturbances or any other events in the network, with very graphical visualizations when it comes to the one-line diagram, the results, as well as the plots that are necessary to understand and evaluate the stability of the system. So transient stability itself has been enhanced to include new actions such as generator prime mover action that you can also visualize, the mechanical power changes. We've included plots for components such as the power grid, 3 winding transformers, as well as the static loads. And you can also now display the current and voltage angles directly on the one-line diagram. One of the other nice things that we've added to transient stability is the ability to calculate and report the symmetrical components when we are performing any kind of grid code analysis. And then finally, there is mutual coupling that's also considered for transmission lines as part of the dynamic stability of the system, in addition to the load flow assessment with the mutual coupling as well as the line impedance changes as a result of the mutual coupling. But one of the most exciting things is taking the dynamics and the enhancement to the dynamics and combining and unifying it with protection. And by doing so, we can simulate and validate the settings for all the protective devices in ETAP now with ETAP 2024, such as the overloads, the overcurrents, differentials, distance functions that can include out-of-step relays within the transient stability module, all within the click of a single button. So by going into the analysis mode for protection, such as star Z, you can essentially launch the transient stability module and you can assess all the symmetrical components and all the protected devices that are supported in star and star Z modules in a unified fashion. So this allows you to unify the simulation, avoid creating complex configurations, and evaluating the protection separately from the stability of the system. And with this unification, the doors that are opened include evaluations of power swings, loss of excitation, cascading events, and many more which were more complex to analyze. And with more events that you're able to analyze in a simplistic way, it allows you to analyze more permutations and combinations and go wider in your system-wide area protection and control evaluation rather than narrowing yourself to certain regions alone. So by unifying dynamics and protection with a single click in a single mode, you're able to bring in the protection information with dynamics and assess the impact together at the same time. Of course, ETAP star is our module that we use for automatic evaluation of protected device coordination. And of course, it can also be used in a manual fashion when you're not using the auto evaluation to intuitively create your time current characteristic curves and perform your protection coordination and selectivity accordingly. Of course, when star is combined with auto star, which does the automated evaluation, you unlock the full power of protection and coordination by allowing ETAP to assess the protection and coordination or selectivity capabilities within your system, pinpoint the issues, especially in a meshed system, make corrections, and quickly evaluate once again whether your changes solved the protection or coordination challenges within that particular system. Star, we have in capabilities. So for star, what we have done is we've added the energy and current limiting curves for molded case circuit breakers, as well as the ability to display the current limiting curves for fuses. And once that is done, we are then able to do the following. We can auto-evaluate the cables now based on their let-through energy, and we can also evaluate the cable withstand versus the molded circuit breaker let-through energy. And the verification of the permitted voltage drop can also be done based on a rule book that is established within star. So this is a new characteristic view that allows you to visualize the let-through energy with respect to current and evaluate this with AutoStar along with your existing protection and coordination evaluation all in one shot. We've also enhanced the star view as well as the sequence of operation by allowing you to display various additional fault types such as line-to-line, line-to-line to ground fault types that you can display in the star TCC. And you can also perform identification of trip units with the ZSI capability inside the low voltage circuit breaker. And you can also identify the current limiting fuses and low voltage breakers directly within the editor, essentially allowing you to quickly find devices that have ZSI capability before you select these devices for your protection and coordination purposes, allowing you to again make the correct design choices with efficiency and speed. We've also enhanced unbalanced network load flow, which is a unified AC and DC unsymmetrical system power flow. We've enhanced it to include an analyzer. This analyzer allows you to run multiple scenarios and then most importantly, compare the results and analyze the results from multiple scenarios all in one table or one spreadsheet. And once you analyze the results, it not only gives you the analysis in terms of the worst case conditions or worst case loading, but it can also give you an overload condition on your protected devices. So this is extremely important to identify if you have a protected device that may not trip because of short circuit, but it may trip because of a sustained power flow that exceeds its overload rating. In other words, it trips on its thermal ratings. And the unbalanced load flow essentially can help you identify those devices so that you can size them appropriately. And then we've also enhanced, of course, the algorithm for faster convergence for special systems as well as large systems by essentially utilizing multiple core capability or multi-CPU capability. We've also added, of course, our DC capacitor as a new element, which is used for simulations in DC load flow, DC short circuit, as well as DC arc flash. And it also complies with IEC 61660 for its equipment modeling, as well as its rating, which you can specify based on cells, packs, as well as banks of capacitance. So this opens up, again, new doors in terms of evaluation of renewable energy systems, DC railway systems, as well as high pulse power applications. Auto transformers are typically used when you want effective voltage regulation, as well as variable voltage is actually a requirement. And we've added 2-winding and 3-winding auto transformers that also include no load power loss, a buried delta winding. It considers eddy current losses and includes various grounding types, as well as the load tap changers, making this a complete package for auto transformer utilization for medium voltage and high voltage applications and simulations. Smart inverters have multiple modes of operation, typically, such as volt-var, volt-watt, and many others. And the ETAP smart inverter includes all of these multiple modes of operations, and it also supports rule books that specify control curves, where you can also user-define your own control curve that is provided by the inverter manufacturer. And we've also included P and Q priority modes, allowing the algorithms to dispatch volts or VARs appropriately to manage the thresholds or the targets that have been specified. We also include the smart inverter constraints and compliances per IEEE 1547 and California Rule 21, which is applicable for modeling and defining and using these smart inverters for simulation. Reliability assessment has also been expanded. The library itself now includes data from IEEE 493 2007 as well as IEEE 3006.8, allowing you to have more reliability data as sample, default, typical data for components where the reliability data is not easily or readily available, or where you want to have reliability data when you're dealing with a brand new design. We've also enhanced the reliability assessment to include unbalanced load flow. And this unbalanced load flow is a step forward in reliability assessment such that it includes constraints for alternative sources. So as we assess the reliability of the system by looking at multiple sources, we also now look at the constraint based on power flow when we switch to an alternate source, whether we can reliably switch to an alternate source and whether the source can actually supply the power that's needed for the loads that are being switched onto this alternative source, which makes a huge impact to the reliability of the system. And with this, we've also added new system indices, 4 new system indices, allowing us to perform the calculation and return the results back based on reliability with up to 18 different reliability system indices, including the 4 new ones, making this reliability assessment very comprehensive when it comes to considering constraints as well as computing the indices. We've also added a whole new module which we call techno-economic analysis, and this is a complex analysis that's done on the investment, operating, and the financing of electrical power systems with respect to the reliability indices. So this techno-economic analysis is run in conjunction with the reliability analysis module, but it also includes additional information such as the asset cost, income, tax, net present value, and it computes all of these different metrics to essentially give you an understanding from a technical and economic perspective how good or bad is this particular design and which changes have you done to the design that improve its overall techno and economic benefit. In other words, it allows you to quickly compare design A versus design B through different scenarios in terms of losses as well as the economics. You can also report the cost-benefit results through an internal rate of return or IRR, and the analysis can be done based on a system or based on an individual feeder basis, allowing you to zero in onto the area where you want to perform your upgrades and get the techno-economic analysis computation done, either in a straight line or declining balance depreciation method. ETRAX is a solution for the analysis and operation of railway traction systems. Very unique in the way it's set up because it includes the mechanical as well as the electrical domains combined together into one single simulation in one click, either for AC or DC or mixed AC and DC systems. We've enhanced ETRAX to include the mean useful voltage indices based on EN 50388 2022. And we've also added the reports and plots to support different unit systems that are used globally. We have informative and analytical substation and train summary reports that are also enhanced. And we have essentially sped up the engine significantly, allowing for better convergence and even shorter simulation time, especially when we are running timetables for a day or even a week. Along with the modeling enhancements, we've also included catenary and return conductor mutual coupling. And of course, the user interface has been enhanced as well, making it much easier to interact and manage the railway system network within ETAP. We've also enhanced our cable system so that we can have the optimal and alternative cable sizes, of course, for our phase and ground conductors. And the one mechanism where this is done is the cable manager. So we've added more columns, more data that's visible to you within the cable manager, allowing you to see the derated values and the derating coefficients. We've also added new cables to our library, and we've also improved the compliance with the latest NEC 2023 standard for all our cable impedances. And finally, the cables, when we are performing thermal analysis, are typically done in an underground raceway system that ETAP provides as a module. And one of the methods in there is near McGrath method, which has certain dimension limitations. We've overcome those raceway dimension limitations by creating a new extended method that allows for larger raceways beyond what was allowed in the near McGrath method. So in other words, you can build larger raceways, larger dimensions with the latest compliance in terms of cables, and visualize not only your cable size, but also the thermal temperature of the conductors. Substation ground grid has also been enhanced by having an expanded conductor and rod library. So these are the fundamental building blocks for the substation ground grid. And when you're done with the grounding design in terms of rods and conductor placement, you can, of course, use the IEEE Green Book method, the finite element method, and now in ETAP 2024, the EN 50522 method for evaluating your ground grid design. We've also enhanced our controllers. These are the controllers that are not only used for simulation, but they're also used to actually control the electrical system. And that's what makes ETAP unique. You can design your controller logic, you can test your controller logic in a closed loop manner within ETAP, parameterize the controller in terms of its responsiveness, its functionality, and then once you're done with the parameterization, you can download that logic directly into the ETAP microgrid or power plant controller hardware, which is then connected to the actual physical devices, and it's automatically controlling those devices in a closed loop manner based on the targets that have been specified. The controllers are used to model microgrid and power plant controllers, but they can also be used to model hybrid or master power plant controllers, which means controllers that also include a mix of load and renewable energy and energy storage. It can also be used to model STATCOMs, fuel cells, sync check relays, grid following or grid forming inverters. And you can also import and perform automatic parameterization of black boxed controllers, which are provided by vendors with proprietary logic. We can also use these controllers for operating training simulator. So these controllers have also been enhanced to include new capability, new functions. We've also improved on our API that ETAP provides, which is a REST API allowing you to use ETAP remotely from other systems. We now actually have a secure HTTPS connection to Data Hub, which is the hub that's used to control ETAP. And you can also implement a Python client with ETAP Py to essentially control ETAP to run various scenarios, studies, get your project data, all from your tools or from a different tool that may be used for a different purpose. So this includes now new functions to get the project data, and it also includes the ability to run studies remotely and in parallel across different machines. And with all of these additions to our API, we continuously improve and enhance our reference documentation, our descriptions, our example codes, and it's a very well documented API. In ETAP, we support number of connectors, and we continue to increase the number of connectors to make sure that we are interoperable with other systems. We are able to consume or ingest data from legacy software and databases, bringing them up to date with ETAP as the latest digital twin platform. And then we are able to connect to other systems that are managing similar data, but perhaps in different domains. One of the things that we've enhanced in ETAP 2024 is a connection to ArcFM using Common Information Model. So we can essentially import geospatial data from ArcFM to ETAP and automatically create the GIS diagram within ETAP, create the schematic, and perform various analysis within the ETAP software. We've also improved and enhanced our support for Autodesk Revit and AutoCAD imports. That includes moving Autodesk Revit bidirectional capability to version 2024 and the ability to import data from AutoCAD, such as the single line diagrams, based on AutoCAD 2024, including new symbologies, new components that are handled, and new, even more intelligent connections for identifying components. We've also enhanced our data exchange with Aviva software, especially Aviva Electrical and Aviva Engineering, and we are also able to enhance the logic, the mapping logic, to handle even more complicated networks that are structured or built within ETAP or within Aviva in a bidirectional manner. The Excel data exchange in the past used to be two different modules, one for fixed format import and one for open format import. The fixed format import was based on a fixed template that ETAP provided. The open format was based on an open template. That means the program did its best to interpret your data and map it over to the ETAP software. We've now combined these two into a single Excel import and allows now for faster digitization and data exchange using the Excel import functions. We've also improved our conversion import from Siemens PSSE raw format, allowing you to build the transmission networks within ETAP and combine it with your distribution as well as industrial or commercial systems, allowing you to solve the complete network all at the same time. And this includes an improved automatic one-line diagram layout that allows us to lay out the mesh system in a more structured manner. We've also improved our import from SKM Power Tools to ETAP, Easy Power to ETAP, updated our support for Esri ArcGIS, so we can now import data from Esri ArcGIS from version 10.8.1 directly into ETAP, automatically create the GIS exactly the same as Esri ArcGIS, and then making sure that we can create a schematic from the geospatial models. As part of this import, we also have implemented phase and voltage propagation for missing data, allowing the users to automatically complete the missing information within ETAP software that may not exist in the ArcGIS interface. And of course, no tool is complete without having a comprehensive set of verified and validated engineering libraries. ETAP provides the most comprehensive engineering libraries that are available in an engineering software that is verified and validated for nuclear use. And this verified and validated library is available to all our customers, not just our nuclear customers. And to this library, we continue enhancing and adding new modules. And you can see that we have added significant number of new modules, almost 20,000 new library updates in various protected devices, as well as other equipment such as high voltage breakers, motor circuit protectors, solar panels, power cables, and of course, relays. So it's a very comprehensive library update, and we look forward to you updating to ETAP 2024, and of course, taking advantage of all of these new models that are available in our library. As part of the library, we've also added vendor-specific libraries, and one of those vendor-specific libraries that we've included in this release is differential protection. So this not only just includes a generic differential protection, it goes beyond just a trip time characteristic of the differential relay. This library allows you to model the slope differential characteristics of a differential, whether it's for line, transformer, or bus differential. So now with ETAP, you have the ability to have a generic differential relay with restrained fault and its characteristic curve, a vendor specific, and combine that, of course, with your distance relays, overcurrent relays, and all of the other protection that you may have in the system for more realistic short circuit protection and arc flash studies. Moving on to our next section, which is enhancements that we have done in ETAP for our operation solutions. We have, of course, enhanced our operator training simulator to make sure that we are able to use all the modules with the plot-based reports, as well as interlock enforcements to make sure that certain devices that have interlocks are available within the operator training simulator environment, making this, of course, the most comprehensive electrical operator training simulator that's available, that's leveraging a digital twin. We've also enhanced our AFAS solution, which is our automated fault analysis system, by enhancing the ComTrade handling, having a better or variable sample rate, better fault type and impedance type identification, of course, for branches that include lines and combination of cables, and branches that include transformers. So it's essentially looking at the fault type and identification of a complex branch that is made up of lines, cables, and transformers. And we are also able to distinguish between permanent versus temporary faults. And of course, graphically visualize and report the fault location onto the diagram at the same time. With AFAS, you can not only do the fault analysis, but we are also now able to look at the CompTrade file and determine, based on a detection logic, whether we are dealing with a fault in the system or whether it's a voltage dip, motor start, motor stop, motor acceleration, all through a means of detecting the pattern and combining that with the digital twin to resolve the differences when we read the CompTrade file, whether it is a fault type event or an abnormal disturbance that may not be of the same nature as a fault. So it's a very sophisticated detection algorithm that's used along with the complex system to not only resolve the location of the fault, but also identify what caused the disturbance in the first place. And of course, AFAS is part of eProtect and part of the overall asset management module within ETAP and an integral part of our outage management system, whether it's for distribution systems, transmission systems, or even any other mission critical facility like airports, data center, etc. We've also enhanced our ADMS solution, especially when it comes to volt-var optimization, by making sure that we have the ability to switch between advisory and supervisory modes. We've included a new web dashboard to visualize the real-time volt-var optimization engine as well as its performance before and after impacts. And we are, of course, able to control various controllable devices in the system with volt-var optimization, such as transformer taps, voltage regulators, capacitor banks, and now smart inverters. We've also enhanced our outage management system, particularly when it comes to our various modules within the outage management system, including crew dispatch, crew management, as well as integration with customer information systems, as well as integration with switch order management. And finally, with any outage management system, we also are able to now resolve when we are dealing with an outage that pertains to a reclosure operation, and we are able to also distinguish which devices actually have reclosures and resolve them differently within our OMS report. SCADA is the foundation for the ETAP operation solution. As the name suggests, it's a supervisory control as well as data acquisition system. You can control equipment directly from ETAP eSCADA in the absence of an existing SCADA in the system. eSCADA or ETAP electrical SCADA acts as your default SCADA system that can connect to various devices such as IoT devices and IEDs using various protocols such as Modbus, DNP3, 61850, IEC 104, SNMP, PACnet, etc. And to this electrical SCADA, we continuously improve our thin client and our web-based client, which now includes SMS notification, trending, dashboards, and role-based user access management. We have also enhanced ETAP SI, which is situational intelligence. Situational intelligence is unique because it takes all your scenarios that you've created in your design mode, in your as-designed system. It takes those scenarios and through combination of real-time data to the existing design digital twin, we can essentially keep running those scenarios on a continuous basis, allowing the operator to have an understanding of the various scenarios that can occur in the system and giving him an indication of which scenarios in his system, based on its current operating state, will impact the system in a significant way. For example, if there is a scenario for starting a motor, we continuously analyze that event, especially when the motor is actually not running in the system. And the operator always knows what is the impact of starting that motor in his system through a tabular fashion, including any violations, in such a manner that he knows that in this particular condition, is it safe or not safe to start that motor. So it's giving you the information ahead of time, proactively, before the action has even occurred. This basically makes a difference when it comes to an emergency condition and you have to make split-second decisions. Having the knowledge of all the scenarios and all the possibilities, allows you to navigate with those insights to a better outcome and recovering from that emergency condition. Situational intelligence, therefore, is not something that's automatically reacting to events in the system. It's telling you what will happen to the system if those events happen within this system at this moment in time, giving you that situational intelligence, that knowledge, that look ahead that you need, again, under potentially adverse or emergency conditions. And finally, we also have improvements to our asset and maintenance management system, allowing us to integrate this with our work order management system, integrated with the ETAP model itself, of course, and making sure that we have ability to audit and document procedures, tests, and maintenance records, and create asset management groups. So this allows us to not only use ETAP as an asset management tool, but also brings you closer to NFPA 70B compliance as a system that already has all of your asset information when it comes to the ETAP digital twin. We've also enhanced our microgrid controller hardware. And of course, the microgrid controller hardware is driven based on the controller element that I discussed earlier. And this microgrid controller hardware can now essentially include the rules and the ability to perform black starts of existing microgrid systems. It uses generation and load forecasting for look-ahead capability. And most importantly, it can now handle multi-networked and nested microgrids, allowing the microgrids to be broken down, to be sharded, to be fractured, to be converted into nanogrids, and then be reformed again into a singular microgrid, and manage these independent subsystems independently of each other, and then together when they're combined again. So this takes a unique amount of knowledge and capability to be able to execute a singular microgrid that understands the digital twin, is able to distribute its functionality when the network is split, and then recombine its functionality when the network is recoupled or resumed or reconnected within the system. We've used this successfully on a number of projects, including this particular functionality, and we've also included redundancy of the microgrid controller hardware. We've also enhanced our power plant controller hardware to include active and reactive power control, provide dispatch priority, power smoothing, and then again, most importantly, we are also supporting multi-networked power plants. So again, one power plant that has multiple points of coupling, but the power is consolidated or pooled together as one system. And this allows the project developers to build much larger power plants that are much larger in terms of geographical distribution, that may connect into multiple substations, but they are configured or understood as one consolidated system and managed and controlled as one consolidated system, even though they're electrically different networks. So this gives us a huge, intelligent, capable, renewable hybrid power plant controller that's available at your disposal, connected to the ETAP software, including the simulation of the controller within the ETAP software. Finally, we come to our cloud solutions, where of course we've enhanced our eProtect offering to make sure that we are able to connect to multiple device vendors, acquire the relay setting file either automatically or manually, process those relay setting files from those vendors, make sure that they're available inside a centralized database and visualized through a thin client, as well as connected in terms of the protection settings to ETAP, allowing a bidirectional flow at all times between the relay information, the ETAP model, as well as the visualization of the information and the differences in terms of the configuration files whenever changes are made to these relay configurations. So it gives a better protection and handling on the commissioning of these systems. And of course, within these centralized views, you can now click and drag bulk settings. You can import bulk settings. You can create your favorite filters. You can create different setting groups. and you can actually have a relay health index overview for each and every particular relay, letting you know whether the configuration within the relay is up to date or different from the as designed system. So the purpose of eProtect again is to make sure that we remove any kind of paper trail and we have a seamless flow of electronic data, whether it's automatic or manual, from the design to a centralized database to the actual physical device, and have differences and validation checks and rules in place at all times. We've also enhanced, of course, our browser-based simulation tool that not only allows you to visualize various dashboards, create dashboards, and view all the information within the ETAP application, such as the eSCADA application, but you can also use this browser-based HMI to perform various simulations, and we continue to improve on this particular application. At ETAP, we consider and we take cybersecurity very seriously. Our R&D practices include penetration testing, cybersecurity scan, static code analysis, including binary code analysis, and we perform these analysis on a continuous and regular basis on our products to make sure that the products that are particularly internet facing are secure and safe for you to use at all times. And of course, this remains a continuous and ongoing activity as we improve and update various packages and products within ETAP. We continue to improve and expand on our cybersecurity posture, and in this release, we have done exactly the same. When it comes to our mobile solution, we're happy to get to our ETAP app version 8, and in this particular version, we've enhanced the ergonomics, the way you utilize the application, the interface layout, the buttons and the button sizes. We've designed them for more efficiency, for better comfort, as we've got feedback from our users. And then, of course, we have improved the dark mode on the Android platform to truly make it an easy and a beautiful experience within the Android platform itself. And you can also now include custom equipment colors directly on the one-line diagram within the ETAP app itself. You can also effortlessly share the single-line diagram using various formats such as PDF, PNG, vectors, JPEGs, whatever suits your need. And you can also share a high-resolution image, a vector-based diagram. It's all at your fingertips. And that's the beauty of sharing with the ETAP app to somebody else within the organization who may not necessarily have the ETAP software. The image capture, which was already an existing feature in the ETAP app, has been made even simpler. You can now actually capture multiple images all in one go without actually navigating away from that particular asset. And if you've already captured a bunch of images for a particular equipment and you forgot to link it, you can simply import those images in one batch, display the images in a carousel, and then do automatic naming for those images, which makes organization a breeze within the application, because you can have hundreds of images for hundreds of components, making it quite unmanageable if the automatic organization is not in place. We've also added the ability to undo your changes, which is of course very easy sometimes to make a mistake. You can easily put a component, you can connect it to a particular device, realize it should not be in that place, and then you of course want to undo your changes effortlessly. So you can now undo your addition, deletion, connection, disconnection, rotations, all the necessary and basic actions that you do within the app with the undo function that we've included, of course, for all the platforms, including Windows, iOS, and of course, Android. We have one more improvement in ETAP 2024, and it's a big one. We have created in ETAP 2024 the very first ETAP electric copilot. And this is where artificial intelligence, or AI, meets electrical engineering. What you can do with ETAP AI, or the ETAP electric copilot, as our first use case, is the natural language search. And what that means is you are able to connect your ETAP model to AI engines like GPT, and gain efficiency by essentially understanding your results, such as your data and study results, directly from the Copilot without opening any report, without really accessing the plot files, and you're able to actually get all of this information directly from the Copilot. And of course, by bypassing or not utilizing any complicated or overly difficult Python scripts. But instead of me talking about it, let's take a look at it in action. The ETAP Copilot is available in the Tools menu, and as soon as you open the Copilot, it requires, of course, for you to have a API key, which can be purchased from OpenAI for ChatGPT, which follows the terms and conditions of OpenAI. This, of course, allows you to make sure that your data that you're using to converse with OpenAI is kept secure. However, the ETAP information is not sent to OpenAI. What we do is we utilize the large language models, the conversing capability of ChatGPT, and mix it with your data that's kept locally on your disk. In other words, we're not training the electric AI of OpenAI with your electrical information. So that way your data can remain secure on your disk, but we're essentially giving you that capability, leveraging GPT to converse and identify certain information within your electrical system. As an example, I can simply go to my Copilot and type in the word hi. And of course, I will get a response back from GPT telling me, hello, how can I assist you today? Tell me more about ETAP. And this conversation is essentially happening with GPT, with OpenAI. And of course, we get a response back that ETAP is a software company and we provide solutions for the power system industry. But now here's where the power kicks in. I can simply ask through ChatGPT a question about my data, which it knows nothing about, but I'm using the power of OpenAI and ETAP together in a secure way to make sure I get the answer I need. So let's clear this and let's ask a question that now is taking advantage of your data and the power of ChatGPT both at the same time. And we can ask a very basic question. Give me the maximum amp flow and device. And now this question is interpreted by GPT. However, the data is searched within your electrical model, and the maximum amp flow is actually 1300 amps and the device is bus 3. And therefore, you can also understand that the reference of this information is actually coming from the study report, the load flow report that we just ran earlier. So with this basic example, you can see that your results stay within your computer and you leverage the power of ChatGPT to converse with your data through the ETAP Electric Copilot. And of course, this is the first step towards bringing artificial intelligence to electrical engineering, and we can hardly wait to bring even more of these use cases to not only benefit the industry as a whole, but to benefit and bring efficiency to the work that you do on a regular basis. In conclusion, ETAP 2024 brings a range of powerful and precise tools to your fingertips with a modern user interface, new analysis capabilities, even more comprehensive engineering libraries, better information connectivity, and of course, the brand new ETAP Electric Copilot powered by AI. We believe these enhancements will not only boost your efficiency, but will also make your experience with ETAP even more enjoyable. So thank you so much for joining us today. Stay tuned for more detailed demonstrations on each of these capabilities that I showed you that are coming very soon.